Okay, so this is the start of our next video, and this lesson will be on two new words in physics, velocity and speed. So these terms, kind of like distance and displacement, mean similar things, but there's some differences and some really key things that we're going to distinguish between those two terms. So take a look at your screen here. At the top, I have a definition for velocity, and so we define velocity as a measure of the displacement over a specific period of time, or a change in time. Speed is a measure of the distance during a change in time. So at the bottom of your screen there, you'll see that definition for speed. Now when I read through both of those definitions, you'll see that there is one key difference between the two terms. Velocity, we use displacement, whereas speed has to do with distance. So it's really important to make that connection. Velocity is displacement over time, speed is distance over time. Also on your screen here, you're going to see a couple of very important formulas. The formulas at first glance kind of look quite similar, but we will talk about, again, a couple differences between the two. So at the top of my screen, I have a formula for velocity, right here. And I see that it is a v is equal to a change in distance, or displacement, sorry, over a change in time. And you'll also see these little vectors, those little arrows that we talked about in the last video. Those arrows, or sometimes you'll see them as just a line over top, mean that this is velocity. So if at the top of my screen, a v with a line over it is velocity, at the bottom I see a v with no line over it, and that means speed. So I use a v as the symbol for both velocity and speed, just whether or not it has the line over it determines which one I'm talking about. Again, with the formula, they're pretty similar. I see a change in d over a change in t in both formulas. Just that formula at the top for velocity has, again, that arrow that we talked about before, meaning it's displacement over time. Another way I can write those at the top here is d2, or displacement 2 minus displacement 1, over top of t2 minus t1. Same thing at the bottom, d2 minus d1, over top of t2 minus t1. Also, you'll see in that box there, very important, velocity is a vector quantity, so every time I'm solving a velocity question, I need to have a direction at the end. So I'm going to walk you through a couple of practice problems that we'll do together here, so you can write these down. Then at the end of the video, I'll give you a few examples to try on your own. Again, I really want to stress the importance of that three steps every single time, showing my formula, showing my work, and my answer. So this question says, a duck skateboards 35 meters east in 7.0 seconds. What is the velocity of the chicken? I think that's supposed to say duck. We'll just go with that. My first step is always going to be my formula. So with these questions, I'm going to start with the same formula, a change in d over a change in t. Now, if this question asks me to solve for speed, I could leave my formula like that, but this doesn't. This question wants velocity, and that's a vector, so I'm going to put the arrows over top of my v and my d. So now this means velocity is a change in displacement over change in time. So there's my formula. Second step, plug in my work. So I'm going to read through the question and pick out the numbers I want. I see 35 meters, which is my displacement, and 7.0 seconds, which is my time. So I can say 35 meters is my displacement, always in meters, over 7.0 seconds. So I have 35 divided by 7. Hopefully you can do this in your head or grab your calculator. When I type in on my calculator 35 divided by 7, I get an answer of 5. So you can put that there. The important thing here, I need to remember what we talked about in the significant digit video and always round my final answer to the proper number of significant digits. So my 35 has 2, my 7.0 also has 2, which means my answer needs to have 2 significant digits. So I have to add that 0.0 to the end, followed by my unit. So a final answer kind of will have 3 components to it. I'm going to have a number, always to the proper number of significant digits, so that's my 5.0. Next I'm going to have a unit. Here I have a meters per second. The final part of it will be a direction. So I look up in the question, I see that this was going east. So again, I could write out the word east, or I could put east in a square bracket like that. So my final answer would be 5.0 meters per second east. Okay, let's take a look at another example here. This one says an elephant on a slippery sled slides 24 kilometers north in 6.0 hours. What is the velocity of the elephant? So what I'd like you to do is pause the video here, try this question on your own. When you're finished and you have your answer, press play to see the solution. Okay, so this question, really quick, I'll just give you the answer here. I'm going to start with the same process. V is equal to a change in d over change in t. Now this question asks me for velocity here, so I know I need to add the vector arrows on top. So now I have velocity is change in displacement over change in time. My second step will be to plug in my numbers. So I have a displacement right here of 24 kilometers per hour north, so we'll put 24 kilometers, divided by a time of 6.0 hours. So we can say 6.0 h for hours. 24, so when I look at my units here, I have 24 kilometers in 6 hours. A kilometer and hour match, so I can leave those. Just like a meters matches with the seconds, it's fine. So 24 divided by 6 gives me 4, but I need to put this into the proper number of significant digits. So I have 2 significant digits in my 24, 2 in my 6.0, so my answer will be 4.0. My unit here, I have a kilometer on top, an hour on the bottom. So this will be kilometers per hour. Last thing I need to do is add a direction. In the question it tells me this is going north, so I can put an N in a square bracket. Okay, moving on, next question. This question here, I see that I have a car that's driving 150 kilometers per hour. That's a velocity or speed. And then it asks me what is the car's displacement after 3.5 hours. So this time it's giving me a v or a speed, it's giving me a t, and I want to solve for displacement. So I'll start with my same formula. V is change in d over change in t. This question's talking about velocity and displacement, so I'll add my arrows, my vectors on top. Now, the thing about this question is I have to actually rearrange this formula. So I have v is change in d over change in t, but I want to solve for change in displacement. So I want change in displacement is going to equal whatever on the right-hand side of that equation. So right here in my equation, I see that change in time is on the bottom, or it's being divided. So I'll get rid of that by multiplying by a change in time on the top. What I do to the right-hand side, I have to do to the left-hand side. So I end up with, these two will cancel each other out, and I end up with a velocity and a time on top. So I can say this will be a v multiplied by a change in t. So there's my formula. Next step, I'm going to plug in my work. My velocity is 150 kilometers per hour, and my time is 3.50 hours. Just like that. Now I need to figure out a unit. So I'll go 150 multiplied by 3.5 gives me an answer of 525. I need a unit and a direction on here. So to figure out the unit, I will look at the units in my equation here. So I have a kilometers per hour multiplied by an hour. So an hour on the bottom would cancel out with an hour on the top, leaving me with a kilometer. So my units here will be 525 kilometers. In the question, it doesn't tell me necessarily if it's going north, south, east, or west, but I can assume the car is going forward. So my final answer will be 525 kilometers forwards. Okay, last question. What I want you to do here is pause the video, write this question down, and then try it on your own. I'll give you a quick hint here. If I read through it, it tells me a monkey on a motorbike travels 720 meters in 2.00 minutes. So pay attention to those units. I have a meter here, a minute over here, and those two don't match up. So I need to take this minutes and convert it into seconds before I put it into the equation. So I'll take 2 minutes, convert it into seconds, and then plug it into the equation. So try this question on your own.